Good day, everyone. I welcome you into the class of EDT821, Instructional Task Analysis and Psychological Basis of Instructional Media. My name is Dr. Adeyemi Adedapo of the Department of Education Foundation, Faculty of Education, National Open University of Nigeria. The topic we are going to discuss today is systems approach and fundamentals of application of systems to instruction. In today's interaction, we try as much as possible to define a system, mention the characteristics of system. We also explain the types of systems and discuss instructional system. Come along with me. At the end of the interaction, I'm sure you will really enjoy the class. Thank you. Welcome back into the EDT821 class, Instructional Task Analysis and Psychological Basis of Instructional Media. My name remains the same, Dr. Adeyemi Adedapo. During our last meeting, we discussed extensively on task analysis for instructional design. I said task analysis for instructional design as a process of analyzing and articulating the kinds of learning students are expected to know how to perform. Also, we discussed extensively on why do designers perform task analysis, major components of task analysis, the teacher in the process of task analysis, and also description of task selections criteria. Today, we discuss systems approach and fundamentals of application of systems to instruction. Systems approach and fundamentals of application of systems to instruction. Our intended learning outcomes for today's activities. At the end of the interaction, you should be able to define a system, mention the characteristics of systems, explain the types of systems, and explain instructional system. Now, what is a system? What is a system? What we need to ask ourselves, what is a system? The term a system has been variously defined by various writers. We have several definitions of what a system is. But one thing is clear. In all these definitions, the analysis of all the definitions, we have what you can refer to as common elements. So, for example, let's take this one. System is the sum total of separate parts working independently and in interaction to achieve previously specified objectives. This connotes that a system is an object or effect made up of parts that are cooperatively working together, mutually independent, and also functionally related to for a predetermined purpose. Functionally related for a predetermined purpose. Let us consider this Adeoye definition of a system. Adeoye sees a system as an assembly of interacting elements working independently and in interaction with one another in order to achieve common objectives. Also, a system can be perceived by as a method or procedure, e.g. systems of coping with stress in an environment. Others see it as a set of principles or rules linked in an orderly way to show a logical plan, that is, administrative system. But like I said, something is clear. Yes, from the simplest perspective, a system can be said to consist of four things. Let's go back to the definitions of systems we have. The first is object. A system can be said to consist of what we can refer to as objects. The objects are the parts. They are the elements or variables of the system. So these objects may be physical or both, depending on the nature of the system. Secondly, a system consists of attributes, the qualities of the system and its objects. These are the attributes. When we consider this now, sees a system as an assembly of interacting elements, working independently and interacting with one another to achieve common objectives. And also, a system must possess internal relationship. They work together, interaction with one another to achieve predetermined objectives. So this characteristics is a crucial defining quality of system. It's a crucial one, that is defining quality of system. A relationship among objects implies a mutual effect. Mutually independent and functionally related for a predetermined purpose. Also, the fourth one, system also possesses an environment. Yes, a system does not exist in a vacuum, because a system is affected by the surroundings, by the environment. So with this now, with this, the analysis of these definitions reveals certain attributes of a system as follows. A system is assumed to be surrounded by an environment, otherwise known as suprasystem, because the system consists of subsystems. So the environment is now being referred to as suprasystem. So the system also releases the products of its internal processes in this same environment. So a system is made up of different parts which are related to the other. So these parts work together for the overall well-being of the whole. These parts are known as a subsystem. Also, one of the attributes, a system is organized to achieve a goal. No system exists without a goal. This means that each system is goal-serving or value-lending. So the parts of a system are interdependent and functionally related. This means that the parts work cooperatively to achieve previously specified goal or objectives. Systems could be natural System could be artificial. System could be both at once. Example of natural systems include solar system, ecosystem, and body system. An example of artificial system, that is man-made systems, include computer system, highway system. Examples of natural man-made system include hydroelectric power system, water supply system, and also farming by irrigation. So each system has its own boundary, which can be closed, or open. Can be closed, at the same time can be opened. So most systems are open and they continuously interact with other systems within the supra system. Most systems are opened and they continually interact with other systems within the supra system. System is relative. What somebody considers as a system may be seen as a subsystem by another, or same person at different times, depending on the perspective from which it is being examined, depending on situation. What you see now, as a suprasystem, we also be referred to as a system or even a subsystem, depending on the situation. For example, we are trying to analyze a motor car. A motor car is a system. So parts within motor car, like brake, like engine, like tires, shock absorber, radiator, and so on and so forth, are subsystems. A motor car now is a system. Any identifiable, any parts that can be identified within that system can be referred to as subsystems. Any identifiable ones. But the moment we still want to find out what other things are within, for example, the radiator, we still have, carburetor, we still have other parts inside the carburetor as a whole. We have kits there. Or inside the engine, we still have other parts. We have piston there. We have rings. We have con rod. So for us to make reference to this, it means that we will now change the name system that we have given to a motor car to supra system, so that will now be referred to parts like engine as system, and parts within engine as subsystem. That is, we are changing we are changing from a system to supra system, or from supra system to system or to subsystem. So that is one reason why we are saying system is relative. It's a relative term. So what somebody considers as a system may be seen as a subsystem by another, or same person at different times, depending on the perspective from which it is being examined. Systems are multidimensional. Whilst a system could be as large and complex as the entire universe, another system could be as small as an atom. So also, we need to also discuss types of systems. We have open versus closed system. We have open and closed system. We have simple and complex system. We have macro and micro system. Open and closed system. A system is open if its boundaries have breaks which enable systems to interact with its environment. The bigger the breaks, the more open the system and the more input it has to cope with. On the other hand, a system is said to be closed when the boundary of the system is opened, not easy to penetrate. It's closed. When it's not easy to penetrate, a system is closed if its boundaries are sealed off from its environment. Sealed off from its environment in such a way to forestall interaction between the system and its environment. Also, we have simple and complex systems. The main determinant of simplicity or complexity of a system is the input. The more varied or complex the input is, the more complex the system and its input. Conversely speaking, the less varied the input, the less varied the output shall be. We also have macro and micro systems. The two words, macro large and micro small, are relative. So macro systems are more complex than the micro system. Nigerian educational system at the federal level can be described as macro, while at the state or local level is micro. So we also have deterministic and probabilistic system. Deterministic and probabilistic system. Deterministic systems. This one, deterministic system, refers to deterministic system refers to are sometimes referred to as mechanistic systems. Yes. The behavior can be determined precisely with high degree of certainty or precision. With high degree of certainty or precision. So what are we saying here? We know exactly how the systems behave at any particular time under any influence from the environment. An example is the electrical system, whose behavior can be predicted with high degree of certainty as opposed to probabilistic system. With probabilistic system, e.g. educational system, whose behavior depends upon the information available at a given time. So also we have physical and also non-physical systems. Physical and non-physical system. Physical systems are concrete and observable, while the non-physical systems, ones are conceptual, theoretical, that is process or methodological approach. You just have idea, they have this thing in mind. But physical, are concrete, are observable. We also have dynamic and static system. In static systems, there is a state of equilibrium, but in dynamic system, there is a shift from a state of equilibrium to a steady state. When the opposing states in the system are in balance, the system is in a state of equilibrium. In a state of equilibrium. Dynamic and static systems. When the opposing states in the systems are in balance, the system is in a state of equilibrium. Now, this one now leads up to class activity. Class activity 1. You are to examine the characteristics and types of system. Characteristics and types of system. So I will advise that you pause the video for a while and go through the activity. Now, welcome back. Now, systems approach. Systems approach. We need to ask ourselves, what is systems approach? The word systems approach. Systems approach has been increasingly used in solving educational institutional problems. Not only educational institution problems. So systems approach can be used to solve any problem, be it social, political, religious problem, and so on and so forth. The application of systems approach has made it possible to see education as whole, consisting of several independent elements, which are working in harmony in order to achieve common objectives. You achieve common objectives. Steps in systems approach. Basically, systems approach comprises two major parts. The parts are system analysis and system synthesis. The parts are systems analysis and system synthesis. So under system analysis, we have mission analysis, functional analysis, task analysis, and methods analysis. What are we saying? We have parts analysis, we have functional analysis, and we have task analysis, methods analysis. And also we have system synthesis. We equally have a system synthesis. So with systems approach, we have 7 steps to take into consideration while solving and identify problem. While solving and identify problems. What we need to do first and foremost is to identify problems. There are quite a number of problems that are begging for solution. What a problem solver will do is to break this, identify a problem and try as much as possible to break the problem down and then set objectives. Break the problems down and also set objectives. In breaking the problem down into sizable units, try as much as your task function to, we have mission analysis, the overall objectives. That is common objectives. Now break this one down to, after broken down the problem into sizable units, you task function to each. That is functional analysis. A task function. And then task analysis. Tasks for each of the units. For each unit. We are saying that for under mission analysis, that is, it refers to the determination of the end product of the system analysis. So we are saying that the various steps of identifying an overall mission objectives and the specific measurable performance requirement for the satisfaction of the mission. So the mission is what has been accomplished. What has to be accomplished is what has to be accomplished. That is the mission. So what is required? That is the common objectives for the mission. After it has been broken down into sizable units, you try as much as possible to attach a function to each of the functions there. So we try as much as possible to attach functions to each of the missions. That is mission analysis. It is closely related to mission analysis, to this functional analysis. And then it also consists of breaking down of functions, like I said earlier, identify under mission analysis. Under mission, we have to attach, we have to break down mission problem into sizable units, and then we have try as much as possible to attach function to various components that have been broken down. So we attach function. to various components that have been broken down for functional analysis, functional mission profile. So functional analysis try to leave out possibilities and concentrate on possible options. So this functional analysis centers on a specific rather than general. So mission is the overall function, or attach function to the components that have been broken down. So also we have task analysis. So this one is concerned with the determination of sub-skills that are required to learn and identify tasks. So the task has to be analyzed to actually identify the best strategy that will be implemented in order to accomplish the objectives. We are solving a problem now. If a problem has been identified and try to as much as to break that problem into sizable units for manageable level. So able to manage that such. So you now break such down and then you attach function to each, and then you try as much as possible to identify the best strategies that could be implemented to accomplish. So in doing this, we also need something like methods, that is method means analysis. This step is important because at every stage of system analysis, there is need to consider alternatives that are considered best in terms of speed and accuracy. Take into consideration that is method and means analysis. That is cost-benefit analysis of what we have broken down. We have options, the alternatives, option A, option B, option C. We consider the cost of implementing each of the options that we have identified. So this is what we refer to as. So the system code can be summarized in a model. So here is a model of systems approach. Here is a model of a systems approach. So system analysis, as you can see, we have a system analysis, we have identify problems, analyze problems, and set goals, and then select a solution strategy from alternatives. So here, select solution strategy from alternatives. So when we are trying to select, after analyzing a problem and set goals, we try as much as possible to determine possible solutions. That is perform mission analysis, perform functional analysis, that is perform task analysis, select solution strategies from alternatives, and then analysis. So we try as much as possible first and foremost to determine possible solutions. After taking care of this, we now select solution strategies from alternatives. So from here now, next to implementation, implement solution strategy. Out of the options, we need to take one. Like I said, systems approach is made up of two parts. We have system analysis and system synthesis. The first four, as I said. So the last two is that implementation and evaluation is system synthesis. So after the implementation, what next is evaluation? Evaluate performance effectiveness. After this evaluation, the next thing is feedback. So if there is need for us to modify our objectives, we can still do that. We have options. We have option A, option B, option 3. So we implement. If that one works, fine. So all we need to do is just to implement. After implementation, we evaluate. Evaluation is looking at the strengths and weaknesses of it. If it is okay, fine. If the result is okay, fine. If there is need for us to remodel our objectives, we do that by taking into consideration other things. There are other options there. So from here now, we move on to principles of systems approach. The first one is equal finality. They are saying that the problem we have identified. If identify a problem, try as much as possible to provide solution to such problem. So solving one problem is an invitation to another problem. So once you are done with one, So there are quite a number of problems that are begging for solution. So still take another one. So we have systematize. It's also one of the principles of systems approach. Systematize. Systematize, we are referring to a situation whereby we follow a leader rules. So step-by-step process, is that which recognizes a system as a systematized process rather than disorganized. That is on plan line of thought. The principle of systematized believes that planning based on concrete data should precede actions, and that in planning, orderliness and sequence should be given adequate attention. Even in classroom situation, you see a professional teacher, they move from known to unknown, from concrete to abstract, that step-by-step process. And when we look at this systems approach, it's starting from identify a problem. Once you have been able to identify a problem, you analyze that problem into sizable units, and you try as much as to set goals. So from there, you determine possible solutions. After determining possible solution, you select solution strategy from alternatives. You determine possible solutions. So we now select. After selection, we implement. After implementation, we evaluate. So these are what we refer to as a, systematized process. So planning based on concrete data. So should precede action, and that in planning, orderliness and sequence should be given adequate attention. So also we have principle of fullness. What are we saying as far as principle of fullness? So there is a theory. So this theory of principle of fullness asserts that it is implied that rather than placing emphasis on separate parts of a system, the entire system should be recognized as indivisible whole, of which what happens to any part automatically affects every other part. So we should not place emphasis on a part, but we should look at the system as a whole. So when people are saying standard of education is falling, and they are trying to put their fingers on the teachers or the so-called or the government or the administrator, no, you look at the system as a whole. Don't try to blame anyone, but just try as much as what you look at the system as a whole. So you look at the teaching environment, you look at the teacher, you look at the students, you look at the system as a whole, the input, the process, as well as the output. So also we have principle of optimization. What are we saying as far as principle of optimization is concerned here? Principle of optimization is telling us that everyone that is concerned within it that has something to do should be able to, in a system, should be able to function in a full capacity. If you have anything to do, so the principle of optimization theory is saying that a system design should be able to function in a full capacity to achieve determined objectives. So the goal of a functional system is to apply all necessary input that will lead to a desired output. That is why we have a functional analysis there. All within, all the components must function. So they must produce, they must have what we have desired output. So to achieve optimization capacity, all the units must be seen to be functional. So for example, for a school to achieve its set goals, objectives, all within the school system, the gardeners, the kitchen staff, the administrative staff, the teaching staff, as well as the students need to work full strength, have functioning or no functioning of any of the combination of them might not lead to a successful result. So also we have principle of variety. Principle of variety. What is this? What is this principle of variety? What is it telling us? A variety of ideas. A varieties of ideas. So we have, when we are we determine possible solutions, not just one that you go and implement. And after determining possible solution, in systems approach, in systems approach, we determine possible solution. Not only possible solution alone, we also select solution strategy from alternatives. So we are saying that this principle of system theory emphasizing that the variety as an important element of a system. Variety is an important element of a system. Variety used here encompasses many things. Varieties of ideas, techniques, means, methods, procedures, strategies, and viewpoints. So that within the classroom situation, that is why our teachers, you see teachers at times, professional teachers, they do make use of a lot of ideas, techniques. That is why we have different teaching methods, different teaching techniques, not just one that they use during teaching any process. Combination of all this make good teaching. So we can see apply this principle to classroom situation. So also we have principle environment. What is principle of environment? What is it telling us that, for us to be expecting any good result, the environment must be suitable. The environment must be convenient. The environment must be comfortable. So for us to be expecting any appreciable result, so experiment needs to be conducive. So the system should be made to function in a conducive and appropriate environment that one should expect appreciable results. Consider the input. That is more recent during the period of Abacha. General Abacha. There was problem with as a result of a political problem. It affected the environment. All other systems were also affected, not only education, not only social, not only political. So it affected all other systems. That is more reason why we are saying that for a system to survive, the environment needs to be conducive. So systems only work in a conducive environment. In a conducive environment. These are the principles of systems approach. With this now, let us also consider this. That is a class activity 2. Class activity 2, learners activity 2. What are the characteristics of systems approach and the application to classroom situation? What are the characteristics of systems approach and their application to classroom situation? I will advise you to pause for a while for you to be able to go through this activity. Welcome back. So in this today's interaction, we examined various definitions of systems by different authors. We also examined some of the articles of systems. We discussed the types of systems and took a look at the educational system as well as instructional system. Broadly speaking, systems approach comprise 2 major parts: system analysis and system systems. Like I said, system analysis, we have mission analysis, function analysis, task analysis, and methods and means analysis. Also, we have system systems, which has to do with the implementation and evaluation. So, system analysis. Okay. So, system analysis, on the other hand, like I said, consists of selection of solution strategy, implementation, and evaluation of the total systems. So thank you for your attention. God bless.